Hi guys, this is Ms. Hitzman here, and we are doing TOC number 8. The objective of the topic for this is I can simplify expressions by combining like terms. I went ahead and copied the essential question to the top of my paper, so turning the objective into a question, how can I simplify expressions by combining like terms? So my first question on the left is, what are the parts of an expression? So first of all, let's talk about the word expression. The word expression is simply saying expression is a math problem without an equal sign. Now you may know this already and you may not need to write that part down, but I'm going to write it just in case. Now inside an expression you have multiple pieces. The first part is both of these guys here. These are called, and I'm going to write it bigger, these are called terms. 3 times n is a term, and then this positive 5 over here is also a term. So terms are anything that's separated by pluses and minuses. Okay? The number that's attached to the variable, so this in this case it's a 3. The 3 is called a coefficient. This is pretty small, so I wrote it a little bit bigger in purple. And a coefficient, again, the vocabulary word coefficient, is simply the number that's attached to the variable. The number that's over here by himself, he's called a constant. I like to say that he's constantly alone. And by alone, I mean he is a number without a variable. So let's get into some vocabulary that you're probably familiar with. First of all, a variable is a letter that takes the place of an unknown value. So some number that I don't know yet. Okay? Coefficient we just talked about right above. The coefficient is a number that is attached to a variable. When a number and a letter are together, it means that they are multiplying. So eventually you're going to be given a value for that variable, and when you are, then you would multiply the number and whatever the value of that variable is together. Sometimes, if a variable does not have a coefficient, then it's secretly a 1. So if I just had n by itself, the coefficient is 1 because there's one n sitting all by itself. A term, again, I talked to you about terms up here. Terms are part of an expression or equation, so basically any math problem that are separated by addition and subtraction signs. So you've got to keep in mind that every term has its own sign. It's either going to be a positive term or a negative term. So in this example below, I want you to circle the terms. So follow along with me. Circle the terms with their signs. So again, everything's separated by a plus or a minus sign. So first of all, I'm going to show you that I see 1, 2, 3, 4 terms in here. That means 4 things that are separated by pluses or minuses. Now, I did tell you that they have to have signs, so this 6x happens to be a negative 6x. So my first term is negative 6x. This looks like a plus 3, but if I were to pull this 3 out all by itself, I would bring that positive sign with it. So that term is a positive 3. This 2x, after the minus sign, if I were to pull the 2x out all by itself and it was all alone, I would have to bring that minus sign with it. So now I would read that as negative 2x. My 9 here, after the plus sign, is considered a positive 9. So in this problem, I have 4 terms, 4 different terms. Okay, again, referring to the top example, a constant is just a number that's always alone. Okay, it's by itself. He's constantly alone. He's not attached to a variable. And just to do a quick review of the way top of the notes, an expression is a math problem without an equal sign, whereas when we start dealing with equations, it does have an equal sign. Okay, so now I'm going to get into the details of all of those parts, which is just our basic vocabulary of what I needed to know before I can actually combine like terms. So if I move down here to the bottom of the notes, the question says, how do I combine like terms in an expression? If you happen to have different colors at your desk, I think that's a great idea because once you copy down the expression, I like to practice using different colors to identify the ones that can go together. Okay, otherwise, if you don't have different colors, you can simply use different shapes when you draw around, and you'll see what I'm talking about. It says first to combine the variables. If there's more than one different letter, example A's and B's, go in alphabetical order. Then you combine the constants. So let's look for the variable terms first. I'm going to put a circle around this one because it has an x. That's a variable, so that would be considered a variable term. And then this 2x as well, don't forget it's minus sign, so that is a negative 2x, right? Now, again, you can use a different color or you can use a different shape. I'm putting an orange box around the constants, okay? So I like to set myself up a little table over to the side, okay? And in my table is where I'm going to start combining. I'm going to put my variable terms on one side and my constants on the other side. So here I go. So my variable terms is negative 6x and a negative 2x. My constants was a positive 3 and a positive 9. The reason that I stack them up like this is because it makes it a whole lot easier to put them together. And my purpose in combining like terms is to shorten my math problem, to make my expression shorter, therefore it's easier to work with. So if you grab your calculator, you can put together 3 plus 9. 3 plus 9 is 12, right? And if there's no sign in front, that means it's a positive 12. Over here, if I had a negative 6 and a negative 2, I would have a negative 8, okay? And if I have trouble with my positives and negatives, I can always read that and type it into my calculator as negative 6 minus 2. So now, if you notice, once I have put them together, my expression becomes much shorter. My math problem is now much shorter. I put my x terms together into negative 8x, and I put my constants together and made a 12. Right, so let's do the next ones. So on the second page, you're going to go ahead and copy, if you're writing on your own paper, copy down the problem. If you're doing it on printed paper, then you can just go ahead and start with either your different colors or your different shapes. So again, variable terms first. I see a 4a, and I know that it's positive because there's no sign in front. Okay, I see a 5a, and remember to keep that minus sign with it, okay? Now I'm going to switch colors. I see a positive 9 as a constant, a positive 8, and a negative 3. So remember, my habit was to separate into two columns. I have all my variable terms on one side and all of my constant terms on the other. So my variable terms, I had a 4a, which happened to be a positive, and a 5a, which is a negative. Okay, my constants, I had a positive 9, a positive 8, and a negative 3. All right, so grab that calculator. 9 plus 8 minus 3. Well, I know 9 plus 8 is 17. 17 minus 3 is 14, and that is a positive 14. Now over here, if I were to grab my calculator and type in 4 minus 5, because remember, I'm not going to type in my variables. I'm just typing in their coefficients. 4 minus 5 is negative 1. So when I put all of this together, I have negative 1a plus 14. I have shortened my math problem. Now, a minute ago, I told you that if a variable did not have a coefficient, a number with it, it'd be considered a 1. So in this situation, I could write the 1 if I want to, or if I want to be fancy, I can take that 1 away and just say negative a plus 14. Either one of those answers is acceptable. When you move on to algebra, you're going to see it written like this. But for the sake of Math 7, if you want to keep that 1 there to help you, you certainly can do that. All right, moving on to the next example. I'm going to put my variables together first. So I see a 3y, I see a minus 7y, I see a plus 6y, and a minus 10y. When I'm dealing with my constants, I see a positive 3 and a negative 4. I'm going to go ahead and I'm going to use purple. I'm going to stack them up. My variables on one side and my constants on the other. My constants were positive 3 minus 4. Typing in 3 minus 4, I would get negative 1 for my constant. Now let's put all of our variable terms together. I have a positive 3y, negative 7y, positive 6y, and negative 10y. So this one's a lot longer. So in your calculator, you can type this in as 3 minus 7 plus 6 minus 10. Okay, so go ahead, take a minute, type that in, and you should get negative 8 if I did that correctly. So 3 minus 7 is negative 4, negative 4 plus 6 is 2, and 2 minus 10 is negative 8. So my variable terms are negative 8y, and my constants gave me a negative 1. So when I write that all together, I put them next to each other, my problem will read negative 8y minus 1. Okay, and over here, this was the best choice, but this is also an acceptable answer. All right, so that's the first part of our notes, and that's called combining like terms. A lot of times you'll see people abbreviate combining like terms for CLT, combine like terms. If I tell you to combine like terms, again, I'm just asking you to make your problem shorter. All right, so you might want to pause there, take a little break, and process combining like terms. The second part of our notes, when you're ready to come back, is called the distributive property. The word distribute means to hand something out. So you might want to make yourself a note. If I were to distribute candy to the whole class, I would have to hand out. And what's important about the word distribute is it's only fair when you give everybody the same thing. If I were going to distribute homework, I better give it to everybody or it wouldn't be fair. Same as if I were to distribute candy. If I didn't give it to everybody, it wouldn't be fair. So when we're using the distributive property, we're using multiplication. Here's how it works. We multiply the number outside the parentheses to all the terms inside the parentheses. Always watch out for your negative signs. Lucky for you guys, you have your calculators to help you with that. All right, so when we try to figure out what we're distributing, again, it says the number outside the parentheses. So I find that the 5 is outside the parentheses here. This is saying 5 times 4n. Well, 5 times 4 is 20, and then I have to bring that variable down. So all I've done so far is distribute the 5, meaning multiply the 5. My next job, I gave the 5 here. I also have to give the 5 here. It has to be fair. So this 5 now has to go to the 7. Well, it said watch out for the signs. This 7 happens to be a positive. So now I'm asking myself, what is 5 times 7? Well, 5 times 7 is 35. What kind of 35 is that, positive or negative? It's a positive. So I have to put a plus sign in there because remember, terms are separated by pluses or minuses. So now I have used the distributive property to shorten my problem. Okay, not doing any solving, I'm just shortening. The whole purpose of these notes today is how to shorten your math problems. All right, next one, let's go right below it. This time, the number outside the parentheses is on the back end, and that's okay. So I've got to do 5b times 4. Well, 5 times 4 is 20, and I keep the b. Now I've got to take that same 4 and bring it over here and multiply it by the 2. So 2 times 4, or 4 times 2, is 8, right? Now, since both of these terms are positive, if I have to put a symbol in between to make a math problem, I would put a plus sign. So 8 plus 20b. Some people like to put the term with the variable in the front, okay? And some people keep it as it is. Both of these are acceptable, so I'll put the word or, but I will tell you now that when you get to algebra, they're going to want you to put the term with the variable in the front, okay? For 7th grade, Not quite super important, but when you get to 8th grade in algebra, they're going to want that variable in the front. All right, let's move on to the second column of problems. In this situation, the -6 is on the outside. So -6 times 2a, well, -6 times 2 in my calculator gives me -12, and I keep my variable. Next, I have to do -6 times +5, because remember, I have to distribute to everybody. So -6 times +5, when I type that in, -6 times 5 gives me a -30. My problem now says -12a minus 30. Next example, I have -3 times -4w. So you're typing in -3 times -4. -3 times -4 is +12, and I keep the w. Now I have to do -3 times 6, but wait a minute. Remember I told you every term has a sign? This 6 would be considered a negative. If I pulled that 6 out all by itself, that sign would have to come with it. So this side is saying -3 times -6. And when I type that in, that gives me +18. So here is my shortened math problem after using the distributive property. I believe a moment ago I told you when a variable is all by itself without a coefficient, it means 1. So I'm going to slide a little 1 in there. Okay, so that's really a -1a, and that's a +1a. -7 times +1 is -7a. -7 times 9, but if I pulled that 9 out alone from the problem, I'd have to bring its sign in front. So that's really -7 times -9. And when I type in -7 times -9, I get a +63. One more example, and then we're going to put it all together. Find the guy outside the parentheses, and he's who you multiply to, everybody. So this is 2 times -1a. 2 times -1 is -2, keeping the variable. If I pull this 1 out of the problem all by itself, I take that minus sign with it. So it's really saying 2 times -1, and +2 times -1 is a -2. All right, so the first half of my notes, I've combined like terms. The second part of my notes, I use the distributive property. The final part of my notes, if you want to pause here and take a little break, these are my last two problems you can come back for. This is combining like terms and distributing mixed together. So here we go. You're always going to want to distribute first and combine like terms second. Okay, always in that order. That's really important. So grab your calculator. Let's distribute first. Whoever's touching the parentheses is doing the distributing. So it's 1/2 times 4b, and then 1/2 times, that's a -6, right? It's a 6 in the problem, but if I pull it out by itself, I have to bring that sign with it. So if it makes you feel better in your calculator to type 0.5 instead of 1/2, that's okay. So 0.5 times 4b, or 1/2 times 4b, gives us 2b. Now take that 1/2, or the 0.5, and multiply by -6. Okay, so here this is saying 1/2 times -6. Now remember, you can type in 0.5 times -6. That gives you -3. Now I have to bring down the rest of my problem because I haven't used these yet. Plus 6b plus 10. Make sure that when you have a 6 and a b that you make them look different so it doesn't become a 66. That's important. Now I'm going to start combining like terms. And I'm going to put my letters together first. I have 2b, and 6b, remembering to circle the sign in front of each term. 2b and 6b, they go together because they both have a b. Now this -3 and +10, those are my constants. So think back to the beginning of our notes when we set up our two columns, and I'm going to write in this space because you guys type your summary in your digital notebook, so you're not going to need this space here. So I'm going to use it for some math. So I'm going to make my two columns. I have my variable terms on this side and my constant terms on this side. My variable terms were 2b and 6b. My constant terms were -3 and +10. So when I type in 2 plus 6, I get 8b. And when I type in -3 plus 10, I get a +7. So my shortened answer for this first question becomes 8b plus 7. So I took this entire problem, this crazy looking problem, and I shortened it down to 8b plus 7. I don't know about you, but this to me looks so much easier to work with than this up here. All right, let's do one more example and then we're done. I did save a tricky one for the end. If you notice, who is outside of the parentheses that I have to distribute? Well, the -8x is in front, but this -3 is the one that is connected to the parentheses. Now, I say -3, you probably would have just guessed it's a 3. Correct, it is a 3, but when I pull that 3 out, if it was all alone, I would have to pull that negative sign with it. Okay, so remember, we distribute first and combine second. So I'm going to ignore that -8x for right now, and I'm going to deal with this distributing. So first I have -3 times 2x, and then my -3 has to be multiplied by my +5. So -3, because remember I have to give that to the 2x, and I have to give that to the 5. And when I say give that to them, I mean multiply. -3 times 2 is -6. -3 times 5 is -15. So I've distributed. Now I'm going to bring down what I haven't used yet, which is my -8x. Okay, so I did my distributing. Now I'm going to do my combining. This term has a variable, and this term has a variable. This term does not. He's a constant. So when I build my little columns, I have my variable terms and my constant terms. My variables were -8x and -6x, and my constant, the only one, was that -15. So I know that this guy is going to be staying the same. In my calculator, I'm going to type in -8 minus 6, and I get -14x. So when I put these together, that's my final answer, -14x minus 15.